Welcome everyone, my name is Jeff Smith. We're here for another week of our Oracle Database Development web series. These calls are being recorded. If you want to mute your lines, that would help us out. This week we've got Keith Laker, and I'm going to turn this over to him and let him introduce himself and the topic. If you folks do have questions, we have the chat mechanism, and I'll help Keith kind of keep an eye on those. And towards the end, I'll turn the recording off in case you want to ask questions over the line without being recorded. So without further ado, here we go. And Keith, you are the presenter if you want to share your desktop. And as soon as I see it, I'll let you know, and then you can go.
You are now the presenter. Okay. So I hope that's...
I can see it, and so I'm going to shut up now. Thanks, everyone.
Okay. So I thought I had the chat window open so I could see questions, but it's disappeared since I shared my screen. Oh well, never mind. Good morning, everyone, or good afternoon if you're on the East Coast. My name is Keith Laker. I am part of the Data Warehouse Product Management Group. I look after the area that we classify as Analytical SQL. And if you've seen a lot of the webcasts that we've done on 12c, you've probably seen this new feature that we've added to the database called SQL pattern matching. And that's what I want to give you an overview of today. So I've made the slides available. You'll see at the bottom right-hand corner here, there's a URL. If you can quickly type that in, you should be able to download this set of slides from today's presentation. And I've moved the URL to the top up here while I talk about the agenda for today. So what my initial thoughts when I was putting this together was there's actually quite a lot of information that we have around this new feature on pattern matching. So I thought what it actually would be, rather than sort of give you an hour-long session of cramming everything in, that I worked with Jeff and we tried to see if we could put together maybe 2 or 3 sessions, sort of bite-sized chunks, so you can get a quick overview, maybe look at the syntax, understand the key concepts. And then on another session, we can do some use cases and examples, looking at 3 typical cases that we use to build this feature, including looking at how you could actually do pattern matching using pre-12c features. So a lot of the analytical SQL functions that we have, the windowing clauses and so on, actually give you some capabilities of doing pattern matching. And we have a lot of customers that have been down that route and have now swapped over to 12c and found significant performance benefits, but also it's simplified their application code and logic, etc. So there's huge benefits to moving to 12c pattern matching. Because there's a lot of power here, there's also a lot of things that you have to watch out for. And we'll look at some of the basic concepts today, things like quantifiers. How do I go through and search for a pattern? And when I find a pattern, how do I advance to the next pattern? And there's things around greedy and reluctant quantifiers as to how much of a pattern do I look for, as much as possible or as little as possible. And then there's this whole dreaded area that crops up a lot of the time, which is this concept of backtracking, which is to do with trying to match as much of a pattern as possible. And that can lead to significant problems with performance, and also errors crop up as well. So it's useful to understand what's going on there. And to help you work through and understand what's going on, we also have some debugging tools. So rather than sort of dump all of that on you today, which will probably be way too much, just going to go into some key concepts and basic syntax. So as I say, if you can quickly jump on that URL at the top there, you should be able to download this slide deck. Okay, pattern matching. What are we doing? Why are we doing it? A lot of the technology that you hear Oracle talk about today, things like Internet of Things, big data, when you collect all these massive data sets, essentially once you've got them, you need to do some sort of analysis. And a lot of that is looking for patterns in sequence of rows. And although we have constructs today, such as regular expressions, that allow you to look inside a column within a row and look within that column and row to find specific elements, what we really need to do now is be able to go beyond that one column and go across the whole row, but also go backwards and forwards when we're actually searching for patterns. We want to compare to previous rows and look forward into future rows and see how that pattern is being identified. And in a similar way to regular expressions, and if you're used to languages like Perl, we have a similar way to define what it is that we're looking for and how we'll search for it. And there's a new SQL construct that's been added called match recognize, which you'll see in the SQL reference guide and also in the data warehousing guide. And in the data warehousing guide, there's a very big section just on pattern matching. So syntax, what does the command actually look like? It's a lot of keywords that you need to get your head around. So we have a basic table expression that we'll look at in a minute, the standard select, whatever it is, select star from, and then we add on the match recognize clause, and then we have a whole series of keywords that allow us to lay out how we want to actually go about finding a pattern. And I'm going to go through most of the words here. You'll see some of the words are actually missed out, well, not highlighted. There is, as I say, a big section in the data warehouse guide that goes through all of this. It is extremely powerful. There's a lot of features in here to sort of go through. But today I'm just going to give you sort of the high level, hopefully give you the foundation where these other elements will then just simply fit in for you and you'll understand how they all work. So that's the new syntax that we've got. So let's look at some key concepts. To help explain this, I'm going to use a little data set that we created for a stock ticker. So we have 3 stock ticker symbols, pricing information over a number of days. And you can download this data set. I'll give you a link at the end. It's actually in the slide deck. There's a GitHub repository that we have that contains all of these little samples and pieces of code that we've put together. So I have this stream of data that's coming in, and there's certain things that I want to look for. I actually want to look for a W pattern where my share price goes down, it goes up, it goes down again, and then it goes up again. And I want to track that particular pattern. And I want to grab the start of the W, I want to grab the end of the W, and I also want to calculate the average price within that pattern as well. And most importantly, I want to then add a further refinement that I'm only interested in pulling out patterns that last, say, less than a week or more than a week. So there's additional filters that we can apply. So that's sort of the little use case that we're going to work through. So let's start by laying out how this code is going to look. So we want to find this W shape in our little ticker stream, and we've got the graph here, just that's mapping out our stream of data that we've captured. So the first thing we do, we have our select statement, we have our from statement, we have our table name that contains our source data. And then we add on the match recognize, which tells the optimizer that we're now actually going to start pattern matching on that stream of data that's contained in that table ticker. So if you like, ticker is my input into my match recognize clause. To go through those keywords that we've got, there's 4 things that basically you need to do. The first thing is we need to organize the data in such a way that we can actually find the pattern. So we will need to divide the data up. If we've got more than one ticker, more than one symbol, we obviously want to be able to find that W pattern for each symbol. So we'll need to divide the data up based on the symbols and bucket it and then order it by the timestamp for each price that we get for each symbol so that we can find that W pattern. So the bucketing and the ordering then allow us to expose that pattern. So once we've set the data up that's going to allow the system to find the pattern, we now need to tell it, what is the pattern? What are we looking for? And how does it recognize that it's found a pattern? So we then go through the definition of things like events and variables that allow us to describe what it is that we're looking for. The next step is to determine what are we going to pass back to the select statement. Within this, we can, as we're searching for our pattern, we can find all sorts of data points. We can find individual points, we can aggregate points, we can run calculations, and we can pass all of that information back to the select statement so that within there you can pull out the relevant pieces of information that you want. And finally, we need to determine how the output's going to be generated. How much information do I want sent back to that select statement? Am I interested in everything, or would I just like summary points returned? Once you've got those 4 steps, you're ready to just hit the enter key and your code should run and you should get some output. So let's quickly walk through this and go through our ticker stream. So step 1, we need to work out how the data needs to be organized to expose the visibility of this pattern to our pattern matching process. So we have keywords such as order by and partition by and order by. I would say probably in the vast majority of cases that you're going to see, you're probably going to use both terms. Both of the terms are, they're not obligatory, so they're optional. You don't have to use them. If you don't use them, the chances are you may get unexpected results. If you keep running it time after time after time again, you're probably going to get different results each time you run it. So the partition by and the order by tend to be quite important. And I just posted an example last week on actually using this to get around a bug in list tag, and partition by and order by probably are optional in that case. I probably don't actually need to use them. But that's probably a slightly different, almost unique use case that's probably not going to be generally applicable. So most of the time expect to use partition by and order by to bucket and get the data in the right sequence. So in our case, we've got multiple symbols, and obviously we want to organize the data by days so that we can see the stock price going up and down, and those up and down movements are in actual fact meaningful. So we'll partition by our symbol and order by our timestamp. So that's the first part. The second part is, what is it that we're looking for? We need to describe to the match recognize clause what the pattern is, how to find it, what does it look like. And we use constructs similar to those languages such as Perl, and it's a similar approach to using regular expressions like you're probably used to from matching within sequences of rows. The big difference here is that we're matching across row boundaries. So you can look backwards and forwards to see if your pattern that you're interested in is visible within that sequence of rows, either going backwards or forwards. And each pattern variable that you're looking for is defined using conditions on those rows, such as, is this row greater than the previous row, or greater than the next row, or less than the last row, or you can do on aggregate. So is the current row greater than the average price for the last 6 rows, and so on. So you've got a lot of flexibility here to define how your pattern is described. And there are certain symbols that you can use, and we'll look at some of those in a minute when we actually see the code as we put this in. So if you're, as I say, if you use the Perl and regular expressions, so on, these expressions will be, these quantifiers will be familiar to you. The key ones really relate to the first 3, where we get into this area of greedy versus reluctant quantifiers. And the way that certainly that you use the first 3, which are very, very powerful because they have no endpoints in effect. So 0 or more, 1 or more matches, or 0 or 1 match. You can see that it's sort of an open-ended approach to searching for patterns. And this is typically where you can hit problems around backtracking and forcing the system to keep going back over, trying to find a match, hunting backwards and backwards and backwards through your partitions to try and find matches for your particular pattern that you're looking for. So in our case here, as we look for our W shape, we're going to look for 4 elements. So a W has a down, it has an up, it has a down, it has an up. So we know we need 4 elements. So that's the first part that you see here. We define it with the keyword pattern, and we put our 4 elements in brackets. Now you notice they've got plus signs with them, and that means, as you can see here, we're looking for 1 or more matches of each of the 4 elements, which kind of makes sense because you're not expecting the price to go down once, or you may only want it to go down once, but typically you're expecting the price to go down on a leg or up on a leg 1 or more times. So we need to use the quantifier plus on each of these. Now the big question is, what does X, Y, W, and Z actually mean? And the next part of defining the pattern is to explain to the match recognized clause, this is what I mean when I say X. So we use the define keyword, we identify a variable, and then we explain what it is. So in this case, we're looking at the current row of price must be less than the previous row. So in this case, we're actually searching backwards up this slope to make sure that the slope is still pointing downwards. At some point, the slope will go back up, at which point we're now into the second leg. So we're into Y plus, and then at that point, we're looking for where the price is greater than the previous price. So again, we're starting to go up this leg. So that's, if you like, the first stage of a W, and the second stage of the W just repeats the first 2 stages. So W, again, we're looking for the price going down, and Z, we're looking for the price going up. So it's fairly easy to understand, hopefully, how this is actually going to work. So I've explained now how I'm going to order my data, what the partitioning is to make sure that I can find these W shapes. I split it by symbol. So if I've got multiple symbols, I'm going to be searching for the W pattern in each symbol. I've ordered it by time. I've explained what a W pattern looks like, how it goes up, how it goes down, and so on, and in what order, how many times I'm looking to see if the price goes down or the price goes up. So now I've got my pattern, I now need to explain to the clause, okay, what am I going to output? Once you've found this pattern, what information do I need to return back? And you have a whole series of keywords that you can use, like previous, next, first, last, to actually pull out specific data points. You can pull out any column from the input table. So our ticker table has 3 columns. It has the stock symbol, it has the date stamp, and it has price. So I can return any of those 3 columns and put those in my select statement. I can also use aggregate. So while I'm processing through, I can count the number of elements where the price goes down. or I can get the average price, say when the price is going down or when the price is going up, or the average price across the whole of the W from where it starts to where it finishes, or the maximum price or the minimum price. So a lot of the mathematical functions that we have still apply here. In addition, and this sort of gets onto a subject that we'll look at in a future session, we have some special built-in attributes that you can use called classifier and match number, and we'll have a look at those in a minute. So to define the output, what my select statement is going to actually return or consist of, we use the measure keyword. And in this case, I'm going to use the functions first and last, and I can reference those by the variables that I've defined. So I can say X is the start of my W, and I actually want the first X that I find, and I want the timestamp of X, and I'm going to call that first X. So that's going to be right up here. That's the start of my W. And I'm going to use the last function, again, to grab the timestamp, and this time for my variable Z, which defines the end, the last up that I'm actually going to find. So those are the two key variables that I'm actually going to pull out and return back to my select statement, the beginning date and the end date for my W. If I want to check how this is being applied, so if I'm not getting the results that I think I should get when I run this, I might want to drop in the built-in measures, match number and classifier, just to reassure me either that the code's working as I expected, or maybe it's not working and I need to change it. Maybe I've got one of those quantifiers wrong, and I need to tweak the way the pattern's functioning. So what does it come out with? So if we look at match number, what it tells us is it breaks the group down, my rows in my table, and tells me when it finds the first W, so the sequence of the price going down, as we see here, 19, 18, 17, then it goes up, then it goes down, then it goes up again. And that's the end of it. So that's the end, that's my pattern done. And then as we look through the data set, you'll see a second W appears where the price goes down, price goes up, price goes down, and then the price goes up again. So it's found another match. So that's the second match that I found. So now I can go back to my data and just make sure that, yes, that is truly correct. That is, those are the only two matches that I could find, and those are the correct rows. So it just helps me debug. You'll also notice in the column here at the end, you've got these symbols, X, Y, and W. These are referring to your pattern variables, X, Y, and W. So again, you can make sure that if you said the price was going to be greater than the previous price with Z, you can then just quickly check that. Yep, that is actually correct. So that should be Z. So these two objects here are really helpful, the classifier and the match number, for debugging and just making sure that you are actually applying the pattern in the way that you were expecting. And of course, we do have relatively simple quantifiers here. And these quantifiers can get very, very complex, as we'll see in some of the use cases, the other use cases that I've got that we can look at later in another session. So I've got my data. I've got it correctly ordered. I have it set up so that I've defined my pattern. I know what I'm looking for. I know how I'm going to look for it. I've checked that it's coming back as I expected. I've set up my measures to return into my select statement so I can get information out about the pattern. The last thing we need to do is look at, okay, how much data do I want to return when I execute this? And we have three options. So I can look at, say, just one row per match. So each time I find my match, it's just the first, just give me one row. That's your match. And you then determine the output that you want to get. or I can return all the rows of my match. So if I go back here, you can see we're actually getting all the rows of our match. You can see some of these are null until we finally hit Z kicks in and we get our match here, and now I get the last point here. This is outputting all rows per match. There are instances where you might want to do all rows per match with unmatched rows. So you would actually return all the rows in the table. And then some of these other columns, like match number and the variable pattern number, or pattern variable that is assigned to it, some of these rows would actually be null as well, for the rows that don't match our pattern, but we are returning. So you have complete control over how much data is returned once we find a pattern. And once we've found a pattern, the next thing to work out is, okay, where do I start looking for the next W in my sequence? And this can be quite important because you might have overlapping W's, in which case, you know, the second up element, down and up element of AW might be the first down and up element of the next W. So you could have overlapping patterns that you need to check for. Or you can, if you know how the pattern is defined, you can tell the system to jump to a specific point, bypassing all the rows that you know are irrelevant, and direct it to restart at a specific point, so such as the last Z, or the last X, or the first X, and tell it to start from that point. So when you're thinking about how you're going to search this pattern, you also not only need to think about how is the pattern defined, but how am I going to know when I've got a pattern and where do I start looking for the next one? Do the patterns overlap? Are they discrete? Can I jump to a specific point and bypass maybe searching through rows for the next pattern that maybe aren't relevant, and so on. So in this case, we're actually going to output one row per match, and what you end up with is this. So I just get 3 rows back. My select statement, I've just decided I'm going to return the first starting point of each row of each pattern, my first X, and the last entry, the last data point for the end of the W. So I just get 2 rows back within my columns. That's my first start date, that's my end start date, the second W start date, end date. So rather than all the rows that we got back where we had null values in there, it just condenses down 2 rows, 2 patterns, 2 rows. Very simple. So there's your difference. One huge set of rows, and the other one condensed, only 2 elements. And you'll see if we start putting in match numbers and classifiers that obviously the match number is still useful. Oops, sorry. The match number is still useful. It tells us that's the first match, this is the second, this is the third, and so on. But obviously, if we're looking at which pattern variable has been assigned, it's not terribly useful because we just get the last pattern, because that's the only element that can be returned. So that's your controlling your output. So that all of that information then gets passed back into the select statement, and that sort of drives how you do this. Now, one of the great things about SQL, and I'm sure this has probably come up in some of Jeff's earlier sessions that have been running, is how agile the language is, how quickly you can take something and extend it and move it on and get it to even do something completely different just by changing a few lines. And we have a white paper that I've linked on here where we've gone out and explained, given where we are today with all this Internet of Things and big data, there's sort of a movement, or there has been a movement away from SQL. Everybody's now coming back to SQL as the language for data analysis. And there are very good fundamental reasons why SQL is still relevant today, and one of them is this agility, this ability to take a use case and extend it like this one. So we've got, if we were looking at this as a standard business scenario, you'd probably get the request, oh, we need to search this stream for all patterns, all W patterns. Just give me all of the W patterns. That's all I'm interested in. And then the next response comes back, oh yeah, but we want patterns that lasted less than a week. Can you make that change? Well, in this case, if we wanted to do that, it's a relatively simple addition that we have to make. We already have X, Y, W, Z. That pattern stays the same. All we actually want to know is, here's my start point, here's my end point. The difference between those two has to be less than or equal to 7. And we can put that in the bottom here. So we just stick an and then we put Z timestamp minus first, X timestamp must be less than or equal to 7. So that automatically then applies another filter to our pattern that allows us to look for a W and then test the length of it and either accept it or reject it, whether it's less than or equal to 7 days. So it's very, very quick to be able to just go in and make changes to this. Some of the other languages that you get where you want to make these changes, it's hard. A lot of the time you end up just throwing what you had away and rethinking the whole thing. SQL, it's much easier to just go ahead and just continually extend that. And then probably somebody will come back and say, but we need the average price. And if you're quick, you'll think, okay, which average price? Do you want the average price of the whole set, or do you want the average price of just one particular element? If you wanted the average price, we could just leave out the identifier here and just say average price, and it would average the price over this whole area. If they want the average price on the last up, because that's the most crucial thing that they're looking for, that's going to determine whether they buy that stock or not, we can stick in the identifier for the variable. In this case, we want it in the last up, so we just add z.price, and that tells us to look in just the elements that match to z, take the price, average it over the number of observations, and return the average price. So you've got a lot of flexibility here in terms of once you've captured the pattern, what you do with it, how you interact with those points, whether you interact with the whole pattern or whether you interact with elements in that pattern, and the types of mathematical functions that you can actually apply within that process of being able to create new data points. Now, there are certain things that you can't do, like put in window functions. Window functions are not supported in the measures clause, but things like average, max, min, sum, count, etc. Definitely are. So there are some restrictions on mathematical elements that go in here. Not many. The most obvious one being, or the one I get asked about most, because that's my area, is, oh, can I put analytical functions in here? No, just the standard mathematical functions. So very quickly we can take a simple use case and start to make it more and more complex by tweaking the measures, tweaking the output that we're going to return, and also filtering the actual pattern and how the pattern's applied. So you have to be running 12c, just to point that out. Match Recognize is part of the 12c database. In many cases, there are ways to use things like analytical functions, recursive widths, and so on, to do SQL pattern matching across rows of data. We have a number of customers that are doing very powerful analysis around pattern matching using 10G and 11G. A lot of those customers that were doing that type of analysis have helped us build Recognize clause and make it a much simpler, easier, and most importantly, faster significantly faster process for SQL processing. It's also a lot faster and a lot simpler than trying to do this if you're looking at big data sets, Internet of Things and all these things where you're typically running in Java as your default language. Trying to do things like pattern matching where the use case continually evolves and the business users come back and say to you, yeah, now I need to find only those patterns that are less than 7 days. Oh, and I need the average price. Oh, and can you tell me the max price as well? Oh, and what's the minimum price? All of that takes a lot of Java code to set up and work with. And we have a very good use case on our SQL analytical page that's linked further on, showing you the difference between doing this in SQL and doing this a similar thing in Java. And it's frightening the amount of code that you have in Java versus SQL pattern matching. So if you want a good reason to get onto 12c and a good free reason, because this is bundled as part of the database, so it's in Enterprise, it's in Standard Edition, it's included, it's not a costed option, it's free of charge, it's all there. This is probably a great use case. I know Tom Kite's mentioned it a couple of times in his. These are the great things about Database 12c. So we're really happy about the feature and the way people are currently using it today. So just to quickly summarize how you use it. One, make sure that your data stream that you've got is correctly partitioned around how you want to find your pattern, whether you're looking for a pattern across all of your data set or within each element of a particular column. Then you need to get the ordering right. So how do I make the pattern that I'm looking for visible? And most of the time, it's probably going to be ordering by time. The vast majority of use cases that I've seen typically tend to be ordered around time. Not always, but most of them. The tricky part really is looking at your pattern and defining that. How do I define the pattern? What variables do I use? How do I look at those quantifiers? Which ones do I use? Am I after greedy? Am I after reluctant quantifiers? And so on and so forth. And it might take you a couple of iterations to go through it, particularly with some of the debugging elements like classifier and match number, to actually hone what it is that you're after. Next step is, what data points do I want to return back to the select statement? Which measures do I want to use? What aggregates do I want to compute? Am I interested in data points across the whole of a pattern, or do I want data points specifically related to a pattern variable? And the last thing is, how much output do I want to give? How much information does the business user want back? Do they want just each pattern as it's found? Do they want the rows relating to the pattern that's found? Do they want the rows and the unmatched rows back? And working out, again, sort of link back to where the pattern is, where do I start looking for the next pattern? So controlling how you're going to process once you've found the pattern. So that's, if you follow those 4 steps, it should get you a long way to solving most of your pattern matching requirements. Now we have a whole series of sites that you might be interested in. Probably the most important one is in the middle there, the little cat symbol, which is our GitHub repository. We have an analytical SQL repository on GitHub so that you can download the scripts that have set up this simple ticker stream, and there's some other use cases there like sessionization. So if you've got weblogs, you have a sessionization example, show you how to do that. We have some learning videos in the Oracle Learning Library on analytical SQL that'll explain it all to you, including pattern matching. And if you want to try this today, you can download the OTN VM that we've used in the developer workshops, and you can pull that down. I think it's just been refreshed with the very latest label 12c, and that contains a pattern matching workshop similar to the one that I've just worked through. And I'll work with Jeff and see if we can set up some additional sessions where we'll go into some of the code, comparing examples that customers have used for 11G versus pattern matching today, with 12C for things like fraud analysis, sessionization, telco fraud analysis, looking at how handsets are used and shared within a community, and tracking that sharing and then blocking those handsets, and maybe some other ones, like, for example, using pattern matching to get around some issues with things like list tag, which is an unusual use case, but a useful one. And there are probably lots and lots of ways that you could use match recognize, that probably maybe don't involve patterns as such, but it is a very, very powerful function. So with that, that's about as far as I wanted to go today. I didn't want to completely swamp you with information. Are there any questions? I don't know if I come out of this whether I can see the chat window. No, I seem to have lost the chat window.
There are no questions in the chat, so you didn't miss anything.
Okay. Okay, let me quickly go back up there. So I did post the slides of this on our OTM page. If you want to download them, as I say, I'll work with Jeff to set up additional sessions where we can explore some of these use cases, 11G versus 12C code, 12C code versus Java, for pattern matching, and then sort of a more debugging sessions. They've had some emails from people already where they're pattern matching, they think they've got it absolutely perfect, and it looks great on a test data set, and then when they let it loose on their production massive table, the performance isn't quite what they're expecting, and it typically results from this issue of greedy versus reluctant pattern matching searches, and sort of disappearing off into what we call backtracking, searching backwards, continually stepping backwards and backwards and backwards to try and make a match for a pattern, and it's kind of interesting when that kicks in, and being able to then debug and understand why you're getting backtracking and how to then reshape your pattern, rethink what it is that you're looking for to cancel out the backtracking and stop it from going backwards and backwards and backwards over huge numbers of iterations. Okay, I can't see any questions.
I'll stop the recording in case we have any shy folks on the phone.
I'm hoping my explanation was...
Don't want to live on YouTube.